Now let's record. What we have here is a system of two inequalities. You graph them both, but what you're looking for is where they intersect with solutions. You graph one, and I'll graph one, and look where the shadings intersect. That's the answer. So if I were to call this guy number 1, tell me everything you know about number 1. All right, you know it's dashed. Well, I heard shade above. I heard that it has a slope of 2. What else do you know? Y-intercept is 0, negative 3. Okay. Now, what about number 2? Tell me everything you know about him. You know it's solid because of the equal to. What else? I will shade below. Slope of 1 over 3. And what's the y-intercept?
0, 1.
The y-intercept is 0, 1. So we're going to graph these one at a time. Do the shading at the very end. Just trust me on this. So in number 1, what's the first thing that I use here out of all of this information? The y-intercept. 0, negative 3, but keep in mind it's a dashed line. 0, negative 3, so it's going to be open circle at negative 3. My slope is 2, so up 2 over 1. This should not be a problem for us at this stage in the game. So there's my slope of 2. It's a dashed line. That's the reason why I've got these open circles anyway. Now it says to shade above. I do not want you to shade this whole region. That's going to get in the way. Just draw little arrows here saying, okay, I'm going to be shading over here so I know where I need to be looking at. But don't shade that whole region. Because the solution set is not just what satisfies one inequality, but it's what satisfies both of those inequalities. It kind of goes back to our discussion that we had in 0308 about systems of equations, finding out where two lines intersect. But here we have where two inequalities intersect, so where their shaded areas intersect. Now, what about number 2? Where do I start? 0, 1. It's solid, so it's going to be a closed circle right here. So solid, 0, 1. Slope of 1/3, so that means I'm going up 1 over 3, so get all of those nice points. I would like to think that at this point in the game we don't have to worry about how did I use the slope to get these points, but I just can get them. Does that look okay to you guys? But it says shade below. Now here's what I want you to understand. With the green line that we have here, we had already limited ourselves to being on this portion of the plane. So when I talk about shading below, I still have to be on this side of the green line, so I'm shading below this guy. So I could do arrows under here like this, but these guys don't really matter. Where is all the shading pointing to? Yeah, why don't you just guys say right there? Yes, right there. You're sitting 50 feet away, right there. Perfect. So you see where the arrows are pointing up, pointing down here, so it's this region. Right there.
Is that all we have to shade, or would you do shade like all above that?
You only shade, the question was, is that all that we shade? And the answer is yes. We only shade what's common to both of them. you can't keep shading over here or down here because it's not common to both. We're only looking for their intersection. But now, speaking of intersection, we have to look at the point where the lines intersect, which is right here. Since you're including the blue line but not including the green line, this would be an open circle, an open point right here. The only way that the intersection point is included is if what? If they are both solid lines, which means the intersection point will be closed. So this whole shaded region right here, not including the green line or the intersection point, but it does include the blue line going out this direction. That is our solution set. Questions about that? So we're just doing two inequalities at one time.